Okay, so this week we're going to use the enrollment data set again. We're going to do a 1 and 2 sample t-test and some other things as well. So I'm going to walk you through it. So it says here, using the enrollment data set, create an average English score from English 1 and English 2 scores. Call it English average. What is the mean and standard deviation of the 3 scores? Run descriptives of all 3 and paste that table here. Alright, so we go here and we're going to go to transform, compute variable. Now everything's popping up on the other screen. We're going to call it English av. And you may have this variable already, I can't remember. I bring over English, so what I did was I selected the parentheses and I highlighted English 1. I already have English av here, but I'm going to do it again. Hit plus, take over English 2, come outside of the parentheses. You can just type it in or you can click it, divide by 2, and say OK. It says change existing variable. I'm just going to say OK because I already have it. Let's go look at my data, and I've actually already moved it up. So what I want to do now is run descriptives on these 3 variables. So I'm going to go to Analyze, Descriptives, Descriptives, and I'm going to grab English 1. I'm going to hold down Shift and come down to English av, bring all 3 over, and just click OK. I'm going to right-click that. I'm going to hit Copy, bring up my homework. I'm going to click a few times, and I'm going to do Control V, and there we go. Now it says on that English av variable, conduct a 1 sample t-test, testing the null hypothesis that mu is equal to 95 for the English average score. Report the findings in APA format, no table, just written with Cohen's D. Okay, so what I'm going to do is I'm going to go back to my data set. I'm going to go to Analyze. I'm going to come to Compare Means. I'm going to go to 1 sample t-test. I'm going to grab English average and I'm going to bring it over. Now what I'm asking is this average, which we found was 82, significantly different than 95? I'm going to guess that most likely it is. So I type in 95. That's all I have to do. I'm going to say OK. Now what do I have? It's giving me the same data that I have up here. This is the same. I have a t of negative 42, which is huge. Degrees of freedom of 398. A significance of 0.001, because we always put a 1 there. And then the mean difference of negative 12.5. So how am I going to write that here? Let me not do that. Let me bring it up here, and I'm going to make it smaller so I can type it underneath here. I'm going to say T, Control V, so make it smaller. 398 is my degrees of freedom, is equal to negative 42.2. P is, when it's the 0, 0, 0, we're just going to say P is less than 0.01. That's good enough. Cohen's D is equal to the mean difference divided by the standard deviation. So the mean difference is this value here, negative 12.5. So we don't need that, it's just absolute value. So we're going to say 12.5 divided by standard deviation of 5.9. 5.9 so I divide that out and I get 2.1, which is a huge effect size. 2.1, very large effect. Okay, so now we have the question says recode smoking into a dichotomous, which means just 2 levels, variable, and call it smoke underscore 2. You will need to change 0 to 0. If you don't do this, it will leave these as blanks, 1 to 1 and 2 to 1. Then use value labels to code them as 0 doesn't smoke and 1 equals smokes. then run a frequency on that variable and paste the output here. Okay, so what does that mean? All right, so if we go to, I've already got the variable. I'm going to delete this, clear it. Okay, so if I go here and I see I have non-smoker is 0, 1 is sometimes smokes, and 2 is smoker. Well, if you smoke sometimes and you smoke a lot, you're still a smoker either way. So we're going to go 0 is non-smoker, and either 1 or 2 is going to be labeled smoker. So what I want to do is I want to go into transform. I want to go into recode into different variables because I don't want to recode over my original variable. I just want to make another one. Let me reset this because I've already done it. I'm going to find my smoking variable. I'm going to bring it over. I'm going to give it a new name. I'm going to say smoke underscore 2. I'm not going to worry about a label. I'm going to click change, and that now says smoking will now be called smoke underscore 2. And let's look at our old values. Well, if you were not a smoker, you were labeled 0. And what I mean by that is you still have to tell it, or it's not going to give it, it's not going to label the new variable, it'll just be blanks. So if you were coded 0 in the original variable, you're still going to be coded 0 in the new variable. And then here we go, 0 is equal to 0. Now if I was a 1, and I sometimes smoked, I'm going to still be a 1. Okay? And if I was a 2, I'm a full-on smoker, I'm still just going to call you a 1. Okay, because I wanted just 2 levels instead of 3. I say continue, I say okay, I see my code down here. I did it already, but I had done it incorrectly. Alright, so now I need to come down here and label it. Okay, so we have 0 is equal to doesn't smoke, not smake, smoke, and 1 is equal to smoker, or smokes, whatever I said. Now let's bring it up next to our smoking variable so we can look at them side by side. So now I have 0 is equal to 0, 0 is equal to 0, 2 is equal to 1, 0 is equal to, yeah, it looks like I did it right, okay? Where we had blanks, we still have blanks. Okay, now the question was, just run a frequency on that variable and paste the output here. So let's go here, we're going to go to Analyze, Descriptives, Frequencies, and I'm going to bring up my smoking 2, if I can find it. There it is, smoke 2, and I'm just going to say OK. I'm going to right click it, copy it, and then paste it. Okay, and it spans across the page, which is fine. Doesn't smoke, 304, smoker, 107. Now it says test the hypothesis that there is a difference in Math 1 scores by Smoke 2. Now this, let me make this bigger. This is not the same as this one. This is a 1 sample t-test. This one was a 1 sample t-test. This one is an independent samples t-test because we have 1 outcome variable, my Math 1 score, and 1 independent variable with 2 levels, my Smoke 2, right? Now we have 2 groups, smokers and non-smokers. Okay, so this is a slightly different test. So I want to go to Analyze, Compare Means, Independent Samples t-test. I click there. And I want to look at Math 1. So let's do Math 2 so I don't give you the answer. Alright, so Math 2 is my outcome variable, and now I'm looking at Smoke 2 is my variable. Well, okay, now I get these little weird question marks, and I have to define the groups. And when I do that, it says Group 1 and Group 2 use specified values. Well, I called Group 1 was 0, and Group 2 was 1. I could have said 1 and 2, but I chose 0 and 1. And then I say, okay, and what do we have here? This is just our descriptive statistics, so this is going to be the exact same thing as what we find up here. Now remember, we talked about the Levine's test. If I have significance here, then I have unequal variances, so equal variances are not assumed, but I don't have significance. P is not low, so the host stays, right? So that means we can stay in this top row, and we come across, and it looks to be that there is no difference in smokers and non-smokers, because if you look at their averages, the average on Math 2 is 69.5 and 68.8. It's almost essentially the same. So they are not significantly different. And so all we have to do is report. Let me make this a little bit smaller so I can see everything I have. Okay, so I have T of 409, and I'm taking 2 away because there's 2 groups. So my degrees of freedom instead of 411 is 409, is equal to this t-value here, not this one, that's an F statistic, this t-value, this one here, 0.824, which is tiny. It's not even 1 standard deviation. Okay, P, and when you have whoops, forgot to write the P. When you have non-significant findings, you usually write the actual significance. 0.41, Cohen's D is equal to, and I have to pull up, let me pause for a second. Okay, so I went and I just pulled up the social science statistics. I just Googled Cohen's calculator, Cohen's D calculator, get all these ads. Alright, so what do we have? Let me look at the output. So we have, let's just say 69.6, standard deviation 8.1, 304. I'm going to put this on my other screen so I can do this quickly. Okay, so the mean of group 1 was 69.6. My standard deviation was 8.2, and my sample size was 304. My second group, I had 68.8, standard deviation of 7.3, and my sample size was 107. I'm going to say calculate, and here I get an effect size of 0.10, which is very, very small. And when you have a non-significant finding, it doesn't usually make sense to calculate the effect size, but we do it just because I want to teach you how to do that. Okay. Oh, I have it in AMA format. We're just going to stick with the APA format. Okay, so then we're saying tested the hypothesis that there is a difference in writing average scores by gender. That's exactly the same thing. We're just going to do a independent samples t-test, and then I want you to use a bar chart or a box plot to visualize this. So I have a chart or box plot, so let's just do a bar chart. I'm going to go to my output, let's go to graphs, let's go to legacy dialogues, let's go to box plot. Simple, define. Alright, so what was it? Smoking 2 was our category, and we did math 2 was our variable. I'll say okay. It takes a second for it to think about it, and like we saw, they're almost dead exactly the same, so we're going to double click and paste that there. Okay. Alright, and then the next one, this is exactly the same. It says test the hypothesis that there's a difference in writing average scores by gender. It's the same thing as what we just did. Instead of smoking, we just go find gender, which is already done for us. And then visualize it with a bar chart or a box plot, and then it says how many of the group are athletes. Well, we have to go and look at our data, and we find athletes. Okay, and I have zeros and ones, and I tell you here that, well, I didn't tell you, 0 is equal to not an athlete, and 1 is equal to athlete. So you need to code your variable first. Zero is equal to not an athlete, and 1 is equal to athlete. Say okay, and then we're going to run a descriptives of frequencies on athlete, and get our numbers here, paste that in, and then it says run a frequency on the variable major. You don't need to paste the table. Look at accounting. There are 3 people who wrote in accounting, but because one spelled it all lowercase, it got counted as a separate choice. What would be a better way to make these data more presentable? Think about making categories. I'm not going to tell you anything more than that, but I will show you what I need. So let's go to frequencies, and I'm going to reset this guy, and I want to find major. All right, that's a nominal variable. These little Venn diagrams mean nominal. I'm going to bring this over, and I'm going to see this ridiculously large frequency table. I don't want that pasted. You don't need to paste that. But I want you to look at the first few. So we had one person who typed in A. Okay? We have one person who typed in accounting all lowercase. 2 people who typed in accounting with a capital A. So really, 3 people in this data set are majoring in accounting. So what I ask you is, what would be a better way to make these data more presentable? And why do you think that it got counted as a separate choice? Just think about that and tell me the answer. All right.